So here we have the product of two functions. What do I mean by that? Well, we've got capital F of x, and we could rewrite it as f of x, this thing right here, times g of x, this thing right here. And so that's like taking little f of x and multiplying it by g of x. And that's what we call the product of two functions. And so we're going to have to use something called the product rule if we want to find its derivative. How are we going to do that? Well, we're going to follow a recipe. Last year, I went through a proof with the class. It wasn't very popular. So let's just forget about the proof and let's just focus on finding the derivative here because that's what you really need to be able to do both in this course and in your upper year courses or even grad school if you're going to grad school. So it says take the derivative of x plus 1. So take the derivative of that thing and multiply it by g of x. And then we're going to add, so we're going to have a plus here, plus the derivative of x minus 1. So that's going to be g prime of x multiplied by x plus 1, f of x. So let's go through this example together, and then we'll come back to this rule. So I want to take the derivative of f of x. Well, the derivative of f of x is what? It's 1. Right? Which is x1 minus 1. And the derivative of g of x is also equal to 1, which is x to the 1 minus 1, x to the power of 0. That's x to the power of 0. That's equal to 1. And so let's combine each of these products in the way that this is commanding us to. And if I do that, I'm going to get f prime x times g of x plus f of x times g prime of x and we're going to get 1 times x minus 1 plus 1 times x plus 1. This is going to be equal to just x minus 1 plus x plus 1, and we get 2x. And so let's formalize this rule. I've kind of done it here, but let's go over it again. The product rule states that if we have a capital F function that can be broken into two smaller functions that are multiplied by each other, we're going to get f prime x plus f of x, so the little function on the level, times the derivative of g of x. And that whole thing is going to give me the derivative of capital F of x, capital F prime. And that's it. That's the product rule. So you need to know it. You need to memorize it. And we're going to come back to it later in this lecture series. Now, before we move on to another rule, I want to ask you the question, does the product rule confirm the power rule? So you might have noticed, or you might have questioned, why am I using the product rule if I've got, I guess here it's a little f of x. Before it was a big f of x. Maybe we should fix that. If I want to find, well, first let me redefine big f of x. We're going to get x squared plus x plus, because depending on how you do your ordering, I've got minus x plus x minus 1, and big F of x was actually could be written as x squared minus 1. Apply the power rule. F prime of x is equal to what? Well, it's equal to 2x, right? It's equal to applying the power rule, I subtract 1 off the exponent, and then I also bring the original exponent down and multiply it by the base. In this case, the base is x, and so we can see that the product rule does indeed confirm the power rule. Now, you might say, well, why do we have the power, or sorry, why do we have the product rule at all? Well, we might get something that looks like this. Suppose I've got x plus 1 to the square root minus, multiplied by x squared. And so you could get something like that. Of course, we're going to need some more tools before we can answer this question. So stick with the videos, and we'll go over a question like this a little bit later. Here's a question for you. See if you can use the product rule. So find the derivative of little f of x here using the product rule. If you want to try it yourself, keep going. I highly recommend you do, but now I'm going to go over and show you the solution. So I'm going to use the product rule. I'm not going to sort of cheat like I did previously and try and use the power rule. So I want to take the derivative of this thing. So I'm going to use the power rule, and I've got 4x. And then I'm going to multiply it by the second product, x to the power of negative 1 plus 4, plus, well, I'm going to take the derivative of this whole thing here, and I get negative 1. Again, I'm applying the power rule. Now I'm going to simplify this, and I'm going to multiply. So hopefully I've taken the derivative correctly, but now I'm going to simplify it. And so we've got 4x times x to the negative 1. Well, that's like 4x 1 minus 1 plus 16x minus x 2 minus 2 times 2 8x to the negative 2. And it's still all equal to f prime x. Now I'll rewrite this. I've got 4x, oh sorry, that's of course just 4 plus 16x minus 2 minus 8x to the power of negative 2 f prime x. And then I'm left with f prime of x is equal to, well, I'll write it as 16x plus 2 minus 8x to the power of 2. And if I wanted to, I could factor out a 2 here, and then I'm left with 8x plus 1 minus 4x to the negative 2. Now I could double check my work here if I wanted to. I could write f of x is equal to well, it's if I multiply out this thing up here, open up the brackets, I get 2x plus 8x squared plus 8x to the negative 1 plus 32. Now, if I use the power rule on each of the individual terms, I get 2 plus 16x minus 8x to the negative 2. And that's the same thing that I got using the product rule. But, of course, be warned, you can't always avoid the product rule. In fact, there are going to be situations where you're going to want to use the product rule, because generally we find it easier to work with the product rule than the next rule we're going to learn, which is the quotient rule. And we'll come back to the product rule after we learn about the chain rule, and I'll tie in some of these tricks that you can use to get to the answer.